as Professor Fang said, this is the last presentation for the whole conference. I hope everyone's still with me. So this is a joint work with Professor Guo Tan. It's about the impact of ad avoidance technologies in the market of video streaming. So some little motivation facts. The market of video streaming has been growing dramatically around the world in recent years. So in the US, most recent statistics is that the market is $10 billion in 2018. And because US is a much mature market, they were expecting a growth of 3% in coming years. But for China, the video streaming thing is still a new thing in recent years. So we see that although it reached about $16 billion in 2018, actually witnessed an average growth rate of 54% in the past 5 years. So most of the video streaming platforms profit indirectly or directly from advertising. So this is a typical business model for the video streaming platforms, which we have this fancy word called freemium, which means free plus premium. So the video streaming platforms would provide a free membership where the audience watches the ad and the advertisers would pay the advertising fee to the platforms. And in this case, the audience doesn't have to pay a subscription fee. And there is another membership which is called the premium membership, which the audience pays a subscription fee and they can watch the videos ad-free. So when there are ads, there will be ad avoidance technologies, which means there are certain softwares or browser built-in features that allow the audience to skip the ads. So this becomes a serious problem to the video streaming platform because they profit mostly from advertising, and if the free members can skip the ad, they won't watch the ads, so the platform won't get paid by the advertisers, and they won't be willing to pay the subscription fee to get rid of the ads. So there's a recent lawsuit in China, Tencent Video versus the World Browser. So Tencent Video is one of the 3 major video streaming platforms in China, and as I mentioned, they provide both of the 2 kind of memberships. The World Browser is a software company providing browsers with a built-in function of ad blocking. Okay, so this picture is very small, but I will explain it. So the picture on the top is the update log of the World Browser. It's posted on July 31st in 2013, where the World Browser promoted that they have added this ad blocking feature as a built-in feature, such that the audience can just turn on this feature and they don't have to watch the ads. And the picture on the bottom is what the users would see when they were trying to configure their ad blocking features. So this is in Chinese, I'll explain. So the first one is no blocking, the second one is blocking pop-ups, the third one is blocking like every ad, and the fourth one is like customization. So as Professor Fang asks, why does the World Browser do this? The idea is if you are providing this feature, the users will be attracted to use your browsers. Because using your browsers means they don't actually have to pay, they don't actually have to watch the ads when watching the videos on the video streaming platforms. And when there are more people using my browser, they give me traffic. I can guide this traffic to other firms that need the traffic, like search engines. And search engines will pay me and they get the traffic. And how does the search engines earn money from the traffic? They earn from letting the traffic watch ads. So Professor Fang is right. They were getting money because they get the money from those who ask the users who avoid watching ads on the video platforms to watch ads on search engines. So currently, what they can do is that they can still make you watch. So, for example, if you are trying to watch a video and the video streaming platform says you have to watch a 45-second ad, and if the users are using this ad blocking technology, the best they can do is that you will still watch 45 seconds of nothing before you watch the ads. Currently, yeah.
What's the point?
The point it's not because they want you to watch 45 seconds of nothing. It's because they don't have the countering technology. They would like to counter the ad blocking software such that you are still watching the ads, but they cannot do that. So it's kind of a technology things going on here. So. I personally have that kind of experience as well. If you were reading some news and you were using ad blocker, yeah, that's a new kind of counter technology used, but it's not commonly used in video streaming platforms in China. Yeah. There's a browser called Liebao. It's developed by Jingshan Software, and it provides this kind of ad blocking features. And it blocks the ads before the videos on Youku, another major video streaming house in China. And Youku said everyone who's using the Liebao browser will be blocked from Youku. But this went on the court, and the final decision is that they paid each other like 100,000 and everything goes back to normal. So it's kind of like they won't do that anymore.
So that means there's no penalty at all?
So yeah, it's kind of like that. So Youku says it's illegal for you to block my ads. And Liebao says it's illegal for you to block my users from your website. So it ended up that the judge says both of you are doing something illegal, so you just pay each other some money and you get it resolved. So here are some more background information. This is kind of like the first lawsuit trial that in recent years the judge says is actually not a foul play of the ad blocking browsers. So every lawsuit before this one, the judge says is a foul play. It's a business foul play. It's illegal for ad blockers to block the ads. So this is what happens on January 26, 2018. So the trial first instance says the ad blocking technologies are actually technological advancements and should be encouraged by the audience as long as they are beneficial to the society. But the thing is, from our point of view, the judge seems to be confusing about what is the benefit of the society with what is the benefit to the consumers. They were arguing that because the consumer is benefiting from it, then probably the society is good. So definitely Tencent Video appealed in the court, and on December 28th, the trial of the second instance says, okay, the judge summarized that the AATs are indeed harmful to the platform's profitability and in turn would hurt the audience and the society who seeks to use AATs. Okay, so basically again, the judge says it is a business foul play for the browsers to have this ad blocking feature. Right. So what happened between these two trials? One thing that I should mention is actually Professor Tan was invited by Tencent Videos, and we actually helped Tencent to prepare a report on the possible impact of the ad avoidance technologies on the video streaming platforms. So our paper is based on our report, but we do explore more into the academic side. Okay, so the report as well as our paper has these objectives. We try first to construct a game theoretical model for the platform competitions, and we derive some analytical results that happen at equilibrium, and we use some calibration and simulation exercise to determine numerically the effects of the ad avoidance technologies in both short run and long run. Alright, so here's a preview of our main results. We see that we derive that as the penetration rate of AATs increases, both the equilibrium subscription fee and platform's revenue should decrease. And if we allow that the platforms to drop their free members, so it's typical for video streaming platforms in China to provide both free membership and premium membership, but it's more of a common practice in the US to provide only premium membership, like Netflix and Hulu. They don't actually provide you with the option that you can pay nothing and you can just watch videos with ads. So we also derive that if we allow that the video streaming platforms to drop their free memberships, as the penetration rate increases, platforms are more inclined to achieve equilibrium where free membership is dropped by at least one platform. And this is shown by our calibration using Chinese industry data. And we also show that consumer surplus would always increase in the short run, where the platform only passively changes their subscription fee. But in the long run, the total surplus as well as the consumer surplus may decrease when platforms respond by even mild reduction in video resources investment. So, alright. So let me first discuss about the model. So we assume that there is a continuum audience of mass 1 and there are n xnt symmetric platforms. Each audience has a valuation VI for the videos on platform Y, where VI is IAD following this distribution FV and independently across individuals and across platforms. Each platform provides the two types of membership that I mentioned. So for the premium one, the audience pays the subscription fee PI determined by the platform to watch the videos ad-free. For the free membership, the audience has to watch the ads bundled with the videos, and the ads would induce a disutility that we measured it as KVI plus D. So K is something that is related to your valuation, and D is something that is not related. So we also assume that there is an audience of mass delta that has access to AATs, but whether they have it or not is independent from their valuation. We assume that these AATs could reduce the disutility from watching ads to zero directly. So if the audience are rational, they should choose the best membership that they have, or they could have an outside option of not watching with a normalized utility of zero. So we immediately see that for the audience who has access to AATs, because AATs could reduce the disutility from watching ads to zero, it's a dominant choice for them to choose a free membership that gives them the highest valuation. So the decision for each platform is to choose the subscription fee PI to maximize total profit. In this model, we assume that the fixed costs are sunk in the pricing decision stage, and also the marginal costs are relatively small, and so we neglected it. So this means that platforms are basically maximizing total revenue. So there are two sources of the revenue. The subscription revenue is PI per premium member, whereas the advertising revenue is phi per free member who watched the ads. The last sentence, we further assume there is advertising revenue phi that is decreasing with delta. So although this is a platform economy that we were talking about, we were not like making things endogenous. So like we know that for platform economy, it's a very common feature that they cross-subsidize one side with the revenue from the other side. So we were simply assuming that there is this free membership, and it's supported by the advertising fee phi from the advertisers, but we were not making them endogenous. Okay, so this is more of a tractability and ease of modeling kind of assumption, but we shall see that this turns out to have some very interesting implications as well. We currently only discussing where the platform we're only offering premium but not offering freemium. We allow that? Yeah. But there are two ways of doing that. One of them is that you could price your premium membership very low. You will see that later. You can price that very low so that no one is actually choosing it, or you could just commit that you don't actually have this service of free membership. So So this we'll see. So for audience without access to AATs, they were essentially facing what we call a both vertically and horizontally differentiated market. The horizontal differentiation is from the random valuation. The vertical differentiation is the typical one. We can interpret the three options as the three different quality price packages. So the premium has the highest quality and the highest price. The free membership has a intermediate quality of 1 minus K and a price of D. Finally, the not watching has both of them as 0. So I use a quote-unquote price for the free membership because this represents the two main differences of our model from the classical models of like vertical differentiation. So first of all, D is exogenous given and not controlled by the platforms. Second, D is not the actual payment received by the platforms. Instead, the platforms will receive phi. Okay. So this makes our model a little bit different from the classical models. So for illustration, we look at the monopoly case first. So this is a typical consumer segmentation graph for vertical differentiation market. You will see that there are three segments. The first segment is those who are not watching, the middle for free membership, and the last for the premium membership. And we will see directly that there is there are certain audience to choose the free membership, we need that the P minus D over K is greater than D over 1 minus K, meaning we cannot price the premium membership too low. Or equivalently, if we price it too low, no one will be treating free membership. And we were essentially providing free. Yeah. So some notations. We made this. This is probably the only assumption we made in this section. We assume that the virtual valuation function is strictly increasing in V. Okay. So we can write out the monopoly's total revenue. There is a RP, which is total revenue, but it was discounted by 1 minus delta because delta of the audience delta of the audience has access to AATs, they don't generate any revenue. And there's a pi p, which we call a unadjusted total revenue. And we can write out the expressions. So I'm ready to present this very long proposition. So there are two thresholds that separates what the optimal pricing rule of a monopolist platform. Don't look at this. This is too terrifying. So this is the better one. So if we have a very high advertising fee, in fact, the platform should provide free membership only. And when we have a very low advertising fee, the platform should provide only the premium membership. And in between, they should provide the freemium thing. And based on our proposition, we are able to come up with this comparative static results that the equilibrium subscription, the optimal subscription fee, and the unadjusted total revenue will be weakly increasing with phi. And because phi is decreasing with delta, and we know that the P star, pi star, and the total revenue will be weakly decreasing in delta. So this is for the monopoly. Unfortunately, for the oligopoly case, we are currently unable to fully characterize the equilibrium. But what we can do is that we can claim if we were now at an equilibrium where all platforms are providing both membership by pricing P above the threshold D over 1 minus K, and we were assuming there is exponential distribution, then we also get the same comparative static result that the equilibrium price P star will be decreasing in delta, and the total revenue earned by each of the platforms will be decreasing in delta as well. So a side product will be, we know that P star will be decreasing in the number of platforms on the market, which is not surprising. It's probably due to fiercer competition. And we claim that the comparative static result should apply to more general distributions. We actually try some other distributions. It turns out that we can show them numerically using calibration. So, but here we were focusing on exponential distribution. It's basically because we can only show that for theoretical results, and it turns out to be very easy to calibrate for this exponential distribution case. So let me elaborate a little bit on how I calibrate it. So for calibration, we use the following data from the video streaming platforms in China. So there are n equals 3 because there are 3 major video streaming platforms. P star is the monthly membership fee, 15 yuan. Delta equals 13%. This is from a report from Page Fair. So Q1, the other 3 are just some statistics that is reported by a consulting company about the current market status, the current status facts of the current video streaming platform in China. All right, and because we have 5 data points, kind of like that, we can calibrate 5 parameters. I would say they were kind of reasonable. Okay. All right.
Why would this is reasonable?
Because if they all fall in the region that we were, so K should be between 0 and 1, right? So K is between 0 and 1. It's kind of like that. We don't actually have further interpretations, and also we have. So one thing that is very interesting is that we actually have.
Depends on what the case, right?
Yeah.
Then it's reasonable.
No, not in that way. Yeah. All right.
You have to wrap up.
Okay, so we show that for the platform performance, we briefly mentioned we consider if the platform could choose to provide both membership or commit to provide premium only. And so we can write out this whole thing in a triopoly game. I'm only listing the payoff for the role player due to symmetry. And we use our calibrated results to simulate the revenues under each possible scenario. So here's what we get. So the current delta equals 13% penetration rate forcing the scenario where it's a dominant strategy for all the platforms to provide both membership as they do in reality. As delta increases, they will tend to drop the free membership. And if there is sufficiently large delta, all the platforms would eventually provide only the premium membership. We also try to do something about social welfare. We shall see that in the short run, where the platforms can only passively change their subscription fee, meaning they cannot do what I mentioned, they cannot commit on providing premium only, consumer surplus actually always increasing. But total surplus is not, because the platforms are losing money when delta increase. But in the long run, what we assume is that platforms can transfer the loss in the revenue into reduction in video resources. So audience would realize a lower valuation, which is reflected in a smaller lambda if they were using exponential distribution. So we consider this thing called the equivalent quality shock. It's kind of like if I have a change in delta, what's the change in lambda that I can restore the consumer surplus? This is something that is not so easy to explain in the remaining time, so I'll just jump to the conclusion. So as delta increases, consumer surplus would decrease if the platform decides to sharply drop their investment, but total surplus will decrease even if the platform only reduces the investment very mildly, or even if for certain deltas, even if the platform decides not to change their lambda, not to invest or reduce investment, it could still be that the total surplus decreasing, and with the possibility that consumer surplus may be increasing at the same time. All right. So conclusions, as I said, increasing penetration rate of AATs will benefit consumers in the short run, but maybe hurting the economy in the long run. The platforms are more inclined to drop the free membership under high AATs penetration rate, and they will have a lower, due to that they have a lower revenue from providing both memberships. So in turn, the audience seeking to use AATs will eventually make the society suffer from this short-sighted behavior. That's all. Thank you.
Thank you so much.